So we're working on 14C, which is all about reciprocal functions. Now a reciprocal function, where f of x is the original function, is just kind of the flipped version. So if we have a function, say 3 square root x, the reciprocal is 1 over that function. So 1 over 3 times root x. If we have something like f of x equals x squared over 24, the reciprocal, we do the same thing, 1 on top, put the whole function on the denominator, so we'll have 1 over x squared divided by 24, and just notice how the 24 will end up on the top for this particular case, and we'll get the reciprocal as 24 over x squared. Now in Trig, the reciprocal functions are sec theta is what we call 1 over cos, and I remind myself this by saying cos is super sexy, or you could think about cos goes with sec because cos starts with C and then sec starts with an S. 1 over sine theta, so my reciprocal of sine, is called cosec theta. And this I remember because I say sine is cozy, which means sine is nice and warm. Again, you can remember sine starts with S and cosec starts with C, so they go together. I don't have anything fun for tan, but the reciprocal of tan is called cot. And I remember this because tan starts with a T and cot ends with a T, so they must be linked together. First example, find the exact value of sec 5 pi on 3. So this is a reciprocal function. We've got to write it in terms of sine, cos, or tan. Is it 1 over sine theta, 1 over cos theta, or 1 over tan theta? I like to remember that, like I said before, cos is sexy, the S and the C go together, so that means sec 5 pi on 3 is 1 over cos of my theta, in this case is 5 pi on 3. Your second step here will be to evaluate, well, what is cos 5 pi on 3? So take a few minutes using trig and the unit circle to figure out what is cos 5 pi on 3. Recall that 5 pi on 3 is pretty close to 2 pi, right? It is almost 6 pi on 3. So I can write 5 pi on 3 as 6 pi on 3 minus pi on 3. And this will help me locate where the angle is on the unit circle. This is 2 pi minus pi on 3. So 2 pi just means I'm at the origin along my positive x-axis. And then I'm going to go down anti-clockwise because of the negative to negative pi on 3. Now I know my unit triangle here has a hypotenuse 1 and side lengths opposite the pi on 3 is root 3 over 2 and adjacent is a half. Notice that cos is indeed positive in quadrant 4. So I have a value of cos 5 pi on 3. Adjacent over hypotenuse, a half over 1, or just positive a half. Three, last and final step. All we do is we put this answer back into my equation at the start, and I'm going to label this equation with a star. So we get that sec 5 pi on 3 is really equal to 1 over cos 5 pi on 3, and we know that cos 5 pi on 3 is positive a half. You don't need to put the positive sign in there. Once you do 1 divided by a half, then we get 2. So that's our final answer. Next question. Find the exact value of cot 405 degrees. My preference here is always to use radians. I just find that I prefer to stick to 1 because it saves me always converting back and forth all the time, and it also helps with my triangles and my identities. So I'm going to choose to change to radians. You could keep it if degrees if you like. So I know 405 degrees is really 360 degrees plus 45 degrees. I know what those two are in radians. 360 is 2 pi, 45 is pi on 4. Okay, remember the 2 pi really just brings me back to the origin. So I'm just really 405 degrees, I go around the unit circle once, and then I plus pi on 4 a little extra. So cot 405 degrees is really the same as cot pi on 4 degrees or cot 45 degrees. Now I have to use this cot pi on 4 and write it using sine, cos, or tan. So remember, which is the reciprocal? Cot goes with tan because they're the only two with t's, so I know that cot pi on 4 is equal to 1 over tan pi on 4. Next step, like we did before, we evaluate the tan pi on 4 part. This one's nice and easy. I'll just do the unit circle just in case for a refresher. So I have pi on 4. I know the sides for this triangle are 1 on root 2, and the hypotenuse is 1. Tan is positive here, so I know that tan pi on 4 is 1 over root 2 over 1 over root 2, which is just 1. Last step. Substitute this 1 value back into our equation. So we end up with cot pi on 4 is equal to 1 over, or tan pi on 4 was just 1. So cot pi on 4, this is nice, is actually 1. Last example. Find the values of x between negative pi and pi such that cosec x equals negative 2. Okay, we start with the usual. So I want to write cosec x in terms of sine, cos, or tan. Cosec, remember, that will go with sine. And cosec, recall, equaled negative 2 in this case. So I'm just going to put that in there. So I can rewrite this equation as 1 over sine x is equal to negative 2. Again, what I want to do is flip both sides. So I have sine x over 1 is minus 1 over 2, or sine x is negative a half. And the last step, we're really going to solve for x within the restricted domain of minus pi and pi. And I'm going to use, again, the unit circle and some trig to do this. Okay, let's draw out our unit circle. Now notice that sine is positive in the first and second quadrant, but I want a negative value of sine, so I'm just going to be looking at the third and fourth quadrant. I know my triangles to put in here, where we have a half over 1, and that will be opposite a pi on 6 for my unit triangle. So then I know that x has a few values involving pi on 6. Now, to make it a little bit easier, I'm going to break my domain into 2 parts. I'm going to find the solutions between negative pi and 0. So I'm going to start at my origin, my positive x-axis, and work anti-clockwise. And I see one solution. Well, if I go anti-clockwise, it will be pi minus pi on 6. And if I go clockwise again, it will be minus 5 pi on 6. So those are the two solutions between minus pi and 0. To find the solutions between 0 and pi, okay, let's have a look. I go from 0 all the way around to pi. I don't see an angle here. There are no solutions. So we only have two possible solutions, minus pi on 6 and minus 5 pi on 6.